Hello and welcome. This is a new episode from Aero Arduino, and in this episode, we're showing to you how to make an autonomous guided vehicle car project. If you didn't yet subscribe, please subscribe to our channel to get the latest videos. In this video, we are showing to you a full project about autonomous guided vehicles, and we are using Tinkercad simulation software to make that autonomous guided vehicle using ultrasonic sensors, three of them, HCSR04, and we are using it to drive two DC motors using the H-Bridge L293 driver, and also a micro servo motor used to steer the motors. And here we are displaying the data from the sensors on the LCD 16 by 2, and also we are using a small buzzer and two LEDs as indication for the car status. Now let's see the hardware components and the connection. First, we start by the H-Bridge L293D. The input 1 is connected to pin number 0. The output 1 is connected to motor 1. Input 2 connected to the ground, because in this case we are using the two motors only in one direction, so we don't need both Arduino inputs to the H-Bridge. Instead, we are using only one input from Arduino. Now, output 2 is connected also to motor 1. Input 3 connected to pin number 1 from Arduino. And output 3 connected to motor number 2. Input 4 connected to the ground. And output 4 connected to motor number 2 also. The 4 ground pins connected to ground. Enable 1 and 2 connected to VCC. Enable 3 and 4 also connected to pins VCC. The power of the IC connected to VCC, and the power 2 used to drive the two motors is connected to 9 volts battery. As we know in previous videos that the H-Bridge is used to drive DC motors or motors with higher current or voltages that we cannot drive directly from Arduino. Now we can see the buzzer. It's connected to pin number 7 and ground, and the LCD is connected to Arduino as follows. The RS connected to pin number 8. The read write is connected to the ground. The enable pin connected to pin number 9, and the data pins DB4 to DB7 connected to pins from 10 to 13, 10, 11, 12, 13 from Arduino, and the backlight LED cathode connected to 1 kilo ohm resistor to the ground, and the backlight LED anode connected to the VCC. Now we go to the ultrasonic sensors. Here are the three ultrasonic sensors. HCSR04 connected to Arduino, so that they are used to map the obstacles and detect the obstacles around Arduino in those three directions: middle, right, and left. You can use this topology and this layout on a real Arduino robotic car. Here are the middle sensor, this one. The triggering pin is connected to pin A5 on Arduino. The echo pin connected to pin A4, that's the input on Arduino. Here is the output and the input. As we know, as we've seen on other ultrasonic sensor projects, Arduino sends an output signal on the triggering pin, and then echo receives the bounced signal on the echo pin as Arduino input, and then Arduino detects and measures the distance of the obstacle according to the time period it takes the sound signal to bounce back and forth. The VCC connected to VCC, the ground connected to the ground. Here also the right ultrasonic sensor connected to Arduino on these pins 2 and 3, and VCC and ground. Also the ultrasonic sensor left connected to 4, 5, VCC and ground. Now here is the servo motor that is used to steer the car. You can consider that this servo motor is used as the steering shaft that moves the shaft that connects those two DC motors, so it can turn right or left or continue moving in the straight direction. Here, this servo motor is called micro servo. As we've seen in previous videos, that it can be driven directly on Arduino because it only takes so minimum voltage and current, so it can be directly driven by Arduino. It has coil, but it uses so small electric current, and it can drive Arduino without any harm. So it connected the signal to pin A1 on Arduino, and the VCC connected to VCC, and the ground connected to the ground. Here directly you can actually, in the real hardware circuit, you can connect that micro servo to right directly to Arduino without any problems. And here are two LEDs, one red and one green, connected through the 1 kilo ohm resistor to pin A0 and pin 6. That was the circuit, and now we can see the code. I leave, of course, the Tinkercad model and the code in the video description. Now, please don't forget to like and share and subscribe right now. Now we continue with our code. We start by including the libraries of the servo and the LCD. Here we start by defining the constant servo as pin A1, and start by defining the servo, and then the pins 0 and 1 of the motors, the pins of the ultrasonic sensors, the middle, the right, and the left, as we've seen in the connection, the buzzer pin, the LED red and green, Now we start by defining the LCD pins 8, 9, 10, 11, 12, 13. Now we define the variables, the duration and the distance. The duration for the middle ultrasonic sensor, the duration for the right ultrasonic sensor, and for the left ultrasonic sensor. And here are the distance for the three ultrasonic sensors. Now in the setup function, we start by defining the servo by using the function myServo, and the method attach servo pin. As we've seen, the pin connected to Arduino, which is A1. Now we set the motor pins as output, the pin mode, output, motor 1 and motor 2, the pin mode on the trigger in the middle ultrasonic sensor as output, echo pin input, and that we repeat for the other two ultrasonic sensors, the right and the left. Of course, as you know, the triggering pin is the Arduino output, the echo pin is the Arduino input, that's the bounce signal. Now the buzzer and the LEDs all are outputs, so we don't have any inputs in this circuit except the inputs coming from the ultrasonic sensors. Now we set up the LCD by using the LCD begin function 16 and 2. As we know that we in this LCD 16 by 2, we start by initializing its status, and then we print the message autonomous guided vehicle initialized. Then we initialize the motor speeds to 0 using the analog write function for both motors on 0 by outputting 0 count on the analog write pins. So we use the PWM using the analog write function, but we use it with 0 count, so the output is 0. The motors are stopped. Then here in the loop function, we start repeating measuring the distance using the 3 ultrasonic sensors by outputting on the trigger pin low on the middle ultrasonic sensor, ultrasonic transducer. We put an output signal low for 2 microseconds, then a high signal for 10 microseconds, then a low signal again, and then using this function pulse in, we see when we get or receive the high bounce signal on the echo pin, and then using this formula, distance equal duration times 0.034 divided by 2, that's the speed of sound in centimeters. We get the distance in centimeters for the middle ultrasonic transducer, and now we repeat this process for the right ultrasonic transducer and for the left also. Now here are the part that drives the autonomous guided vehicle using all the functions and conditions. Now, if the distance is less than 50 centimeters in the middle and in the left and on the right and on the left is less than 50, then we write analog write 0 on motor pins, so the car is stopped and not moving, and then we clear the LCD and write a message on it, obstacles ahead, and stopping AGV, and the buzzer is high, so it's making sound, and the red LED is high, is on, and the green LED is off. The car has stopped. Else, if distance in the middle is less than 50 and on the right is also less than 50 and the left is more than or equals 50, then as you can see, the car can go to the left direction. Here the servo is 120. It has steered to the left, and then the LCD writes turn left. The analog write is 255. On two motors, we use the analog write, so they move by the full speed of the PWM, because we don't control speed here. Now the red LED is off and the green LED is on, and the buzzer is low because the car is moving. And here on the LCD we print the measured distances, the left, the middle, and the right on the LCD as in that layout. Here another condition: if the distance in the middle is less than 50 and on the right is more than 50 and on the left is less than 50, then also the servo is steered to 0 degrees. Then the LCD prints turn right on the upper row. Then the motors are moving. The red LED is off, green LED is on, the buzzer is off. The LCD prints the distances as we've seen before. Else, move forward and display distance on LCD. There's no obstacles. They are away by distance more than 50 centimeters, so that we use the analog write 255 on both motors. The red LED is off, the green LED is on, the buzzer is off. The LCD prints the distance and the layout of the distance as we've seen, and that's the end of the code. Now we start the simulation. We press start simulation and see this circuit in action. Here AGV initialized, then the distance, as we can see, the distance on the right, on the middle, on the left, and the servo. Here it starts by initializing. You can imagine as if the motors are steering in that direction. That's the shaft or the axe that moves the motors. Here it's moving forward, and we can see here the two motors are moving in the same direction. Now we can change the distance and see here the distance 198 on the right. Now we decrease that value. That's 40 centimeters. Let's stop the simulation and start it again. Here, the car is moving forward. If we decrease the right and the middle, then it turns left. There's some error here on the right measuring distance. Maybe that digit is still written, as you can see. We must remove it. Or it's a fault in the readings. Here, if we decrease that to 50, now we get the message obstacles ahead and stopping the AGV. We see that the red LED is on, the green is off, and the buzzer is moving. The motors has stopped to 0 count. Now we increase the distance on the right. Now we see the steering is turned towards right. The motors are moving. The green LED is on. The buzzer has stopped. The red LED is off. And here the measured distances on the 3 ultrasonic transducers. And that's the distance. And here we turn right. Now that's a bug, the running bug. Of course, in the middle, we also need to stop if there is an obstacle. Or turn right or left. Anyway, we can enhance the software, and we wanted to share this circuit with you. I'll leave the link to the Tinkercad model and the code in the video description. So if you like this video, please click like, share, and subscribe. Thank you and goodbye.